So, ladies and gentlemen, once again, every single person on this platform is welcome. We are starting a new topic which is known as regression. Of course, if you've watched the videos, you will notice that we have already done correlation. And so doing regression is not going to be, it's just an addition. Now, regression comes from the world of econometrics. Econometrics is the combinations of economics and statistics to solve economic phenomena, industrial phenomena. But these days it has expanded to several areas of human endeavor and several sub-disciplines of PhDs and research. There are the econometrics and regression that we will consider involve sampling data, building an econometric model. So you got to build a model. Now, what is a model, by the way? A model is a representation of reality. Okay. So a typical example of a model is making a small toy of an aeroplane where you can identify the engines, the avionics, and other parts of the aircraft and manipulating that a smaller aircraft in order for it to fly. And then on the basis of that, you know you can do that to the bigger picture. That smaller one is a model. We will build a mathematical model. We will estimate the model. And from the model, we will make inferences. We will make inferences. There are three kinds of data for econometrics that we shall consider, but we'll consider only two of them. The first one is cross-sectional data. The second one is time series data. And the last one is panel data. I will teach you the nitty-gritties of these data types when we get to the topic on panel data. But for now, we are going to be dealing with cross-sectional data. Just assume that cross-sectional data is a data for 1 year. For example, instead of collecting bank data for 1 year, you collect it across banks and across time. That gives you panel data. But if it is just across banks, no time is involved, just across individual banks, that is cross-sectional. And like I said, we'll dig deeper into this during time series analysis, during panel data econometrics. So econometrics, as I indicated, has been applied in several areas: finance, accounting, medicine, psychology. They apply regression and econometrics. Environmental studies, political science, accounting, marketing, public administration, health, information system. You will apply this in every aspect. So it's not for economists. It's not for financial economists. It's not for mathematicians or statisticians or accountants. It is for information systems analysts. It's for psychologists. It's for medical doctors. It's for marketers, political scientists, and several public admin and several areas. So please, I want you to have an open mind as you dig into this, because this can really, really help you. So we are going to look at regression, and this regression is the offshoot of correlation. And I know many of you will probably understand some few things. Okay, I've been told that majority of the sound across Zoom generally is problematic. It's general. There seems to be a general sound problem. So let's hopefully hope that things will be handling it. All right. So regression is a statistical technique used to analyze the nexus between one dependent variable and one independent variable. And when there is one dependent variable and one independent variable, the kind of regression we talk about is known as a simple regression. So let me just show you something very quickly. And this we have done already. Okay, I'm just giving you a prelude or just recapitulating some few things, and then we'll properly begin. So a simple regression, what is that? A simple regression. A simple regression is that kind of regression, okay, is that kind of regression where you have one dependent variable and then one independent variable. One dependent variable and then one independent variable. That is a simple regression. A multiple regression, okay, multiple regression. That one is where you have one dependent variable and then one or more than one independent variable. More than one independent variable. That sign is greater than. Okay? Greater than one independent variable. So it can be two or more. That is multiple regression. Now, dummy variable regression is another one. Dummy variable regression, you have one dependent variable. Okay, that is dummy variable regression. One dependent variable, and then you have more independent variables. But those independent variables, okay, we have categorical variables among them. We have categorical variables called dummy variables, which are steady dummy variables. Okay, we have dummy variables among them. And then you have the limited dependent variable regression. Okay. Limited dependent variable regression, that is where you have dichotomous dependent variables. So dependent variables can be two or more. Okay, two or more dependent variables, and then again more independent variables. You should know this. You should know this. This one is just passing through. Okay, so keep that in mind. Now the difference between regression and correlation is that correlation looks at the association. Okay, for example, many of you here have correlations between husband and wife. There are relationships which can be measured in percentage terms. If the relationship is very bad, the depth of the relationship is small. The correlation coefficient is small. But if the relationship is strong, then we are moving towards 100%. Now, that relationship doesn't tell us who is causing the relationship to be stronger. It could be that money is causing the relationship to be strong. It could be that in-laws are causing it to be weak or small. It could be that sex is causing it to be weak or small. You know, the causal factors of the moment you bring causation, then we are talking about regression. So a typical example is, what is the effect of education on income? What is the effect of education on a person's income? What is the impact of the hours of study on student grades? Do students who study more hours do better than those who don't study more hours? Okay, regression can help answer. Okay, what are the causal factors leading to the NPP winning the election? What specific factors led to the Biden administration winning the US election? What factors precipitated or contributed to the demise of the former US president? Okay. What regression can answer all of these questions. But in order to do regression, we need to build a model. And so we are going to build a model. And this is where I will beg of you to pay attention, because these model buildings sometimes can scare people. But I'll make it as simple as possible, but you have to pay attention. You have to be writing a lot with your pen. Okay? You have to be writing a lot with your mobile pen or with your pen and paper, so that as we go through it, things will not be that confusing to you. Okay? So what you see here is a regression model. The left-hand side is always the dependent variable. The right-hand side are the independent variable. And this is a high-class lecture. So some of the things, it's not a matter of whether doc, I've never done this before. And so you have to go deep down. No, at the superstructure, super PhD level, you have to dig some of these things yourself. Okay. So it's not where you're going to explain all the details. This is where you bury your head in the book or in a journal to master some of these things. All right. So you have the dependent variable on the left-hand side, and you have multiple independent variables. Each independent variable is multiplied by a beta parameter. The first one is not multiplied by a beta parameter because it's said to be the intercept of the y-axis. Okay. Now, there is a relationship between y and each one of the independent variables. There's a relationship there. And I can actually draw that relationship. Okay. I can say that this is x-axis and this is y-axis. Okay. And then you have some variables that are depicted in there, showing the relationship between x and the y, between x and the y, between x and the y, between x and the y. Okay. And there is a situation where when x is 0, what is y? When x is 0, it means that the value of y will be at that point on the y-axis. So that point on the y. Now that point is a beta naught. That point is a beta naught at where x is 0. Now I can throw a line through this axis. The line will be the mean. Okay. For example, if I give you this line and this line, the mean will be somewhere in there. Okay. And that mean I can make it zigzag, 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 zigzag. Now, this time let me show you. If I have a point here and I have a point here, okay, the mean will be there. But if I have another point here and another point here, the mean will be there. And if I have another point here and another point here, okay, some have started making noises, which is the reason why I normally mute them. Okay. So if I have a point here, a point there, I can now find the middle lane. So if I join these middle lanes, I can create a line. Anytime you have 2 points, you can create a line. So if you have y equals to mx plus c, this is called an equation of a line, where there is a value for the m, let's say 10, and a value for the c, let's say 20, so that you eventually get y equals to 10x, okay, 10x plus 20. This is an equation of a line. If I know the value of x, I will know the value of y. And if I know the value of y, I will know the value of x. Okay. If x is 0, I will know y. If y is 0, I will know x. And I can plot that. So regression that we're about to look at is an equation of a line. Okay. But the equation of a line is where there is one x. But here in a regression, there are multiples of the x. And so let's go back to our equation that we are having here. Okay. So in this equation, what we are saying is that the y, which is a dependent variable, okay, when you are doing structural equations modeling, we talk about latent variables, okay, the observed variables and the latent variables. The latent variables are more or less hidden, unseen. It's a similar principle here. These variables, the x's, they are called observed. They are all observed. The x's are observed. And these are independent variables. Sometimes they are called explanatory variables. There are so many. And because we can't write all of them, we write them up to ki. And then there is one which is known as the ui. Now the ui, and I'll come to them very soon. Okay? The ui is sometimes represented by epsilon I or EI. So these three letters, we'll be using them a lot for the UI. The UI is the unobserved heterogeneity. Or better so, let me make it simple. It's called the error term. The error term. You come to understand why this is called the error term. Let me take your relationship that you have. There's a relationship between the husband and the wife. This relationship, okay, is driven by love. So love, if I were to rewrite this equation here, okay, love will be one of the relationship, one of the variables. Okay, so let me just go there. Okay, so there's a relationship between this husband and the wife, and this relationship is driven by first a constant, and then by beta 1 love. Okay, and then by beta 2 is also driven by money. There are some ladies that will not bother you if you don't have the money. It's also driven by beta 3, and then let's say in-laws. In-laws, they are affecting the relationship. It's also driven by beta 4, sex. Okay. Beta 4, sex. Some people believe that affects the relationship. Okay. In fact, it does. And then beta 5, okay, something like communication, and so forth. But then there are other factors, and those factors are what we call UI. There are other factors that can affect the relationship, the marriage relationship, but those factors are not captured. Those become the latent variable, the factors that cannot explain the relationship. You see, the love can explain the relationship, whether it's strong or weak. The money can explain. The in-laws can explain. That is why these independent variables are called explanatory variables. Explanatory, causal factors. Now, in our own, we just represented them by x1. We can represent this by x2, by x3, by x4, by x5, and so forth. Now, what is the betas? The betas are telling you by how much that particular independent variable is affecting the dependent variable. By how much? You see, love can say that I am affecting the relationship so well. This relationship is so powerful because of the love. But money can also say that, hang on, I am also affecting this relationship big time. Without the money, we are doomed. Now there's a battle. So the question now becomes, by how much does love affect the relationship? Okay, that's critical. So you talk to love by how much? Love affects this relationship by beta 1. Money affects the relationship by beta 2. By how much does sex affect the relationship? Beta 4. By how much does communication affect the relationship? Beta 5. And so those beta parameters are telling you by how much each explanatory variable is affecting the dependent variable. Now, those explanatory variables are therefore known as the causal factors, independent causal factors. And you got to appreciate, you got to attend them. So let's take a typical example. A typical example is y equals to beta naught plus beta 1 x1 plus beta 2 x2. Now, how many independent variables do we have here? And how many beta parameters do we have here? Okay, you can tell me that. How many independent variables? So first of all, you can type in the answer. How many independent variables do we have? Okay, this one is quite simple. Unlike the one that we have at the top where the independent variables are so many up to k, here, how many are the independent variables? Good, I'm getting correct answers. There are 2. How many are the regressors? There are also 2 because the regressors are the independent variables. How many are the beta parameters? The beta parameters, how many are they? How many are the beta parameters? The beta parameters are 3. They are 3. They are 3. One of them does not have an independent variable, but the beta parameters are 3. Okay. All right. Now, the question is that now we know what the x's mean. They mean independent variable, and the beta parameters in front of them are representing by how much the x's affect the y. But there are other factors that haven't been included, which is called the error term, the ui, the epsilon I, the ei. Okay. Now, to be honest, the entire regression revolves around these factors. The entire thing is these ui, these error terms, there are several names for them. We call them the disturbance term, the stochastic noise, the white noise, the idiosyncratic error, the unobserved heterogeneity, and several other terminologies. You just have to get used to some of those terminologies because, you know, life, you are going to meet them some way or the other. Okay. Now, we will come back to these error terms because they are the bedrock of regression. But I want to give you a practical example in real life situations so that you can appreciate this. For example, you will all agree with me that there are factors that can affect your salary, wage. What are those? Well, your education can affect your wage. There's no question about that. Do you agree with that? I'm sure you do, because most of you are earning salaries. So you know that your level of education, in fact, part of the reason why many of you want to upgrade yourself, do postgraduate, PhD, permanent head damage course, more or less, is because that can affect positively your salary, your wage. But it's not only that, your experience can affect your wage. Your position can also affect your wage. In fact, your ability can affect your wage. Now, I want you to think about other factors which is inside this you that can affect your wage, but haven't been included in any of these independent variables. Can you type me any other factor? Now, the factor must be relevant, and I can only decide what is relevant here. Which factors do you think can affect? The type of industry is very good. The industry type is good. The level of risks is the type of industry, it's the same thing. The risks is the type of the industry. Okay. Now, sometimes some people will do gender. I don't believe much that gender should affect your salary. And so I'll drop that for now. It's not that relevant in this post-academic time. Allowances can affect your wage. That is true. The location of the job is critical. People in London actually are paid more than people in the Midlands. That is true. The years of employment will go into your experience. So we can't count that. Okay. Your position has already been mentioned. Your salary scale has already been mentioned. The position has been mentioned. Okay. Age. Age will come by experience and education. Okay. They are all mingled together. The span of control, what is that? What is the span of control? I don't get that. Okay. But indeed, most of the factors you've mentioned are important. Responsibilities is too broad. Skill set will go into your experience. Your school, okay? You are talking about your type of school. Who says that when you are getting a job, okay, they are going to look at the type of university you attended before they pay you? It doesn't work like that. Once they employ you, they employ you. Your productivity type will in itself is part of everything. Relationship with the owner is irrelevant. We don't want to bring nepotism, favoritism into the picture. All right, so we've got enough. At least you guys are beginning to understand, okay, relationship with the boss is irrelevant. Okay, let's be very objective. No nepotism, no favoritism, no tribalism, no racism. We don't want to include those factors in there. If your dedication to duty is inside your ability, it will be captured in your ability. Let's go to another factor. Blood pressure. Your blood pressure is affected by your age. There's no question about that. Watch the way I'm formulating the model. I bring I in each one of them because we are dealing with cross-sectional data. Your blood pressure is affected by your age. I'm sure you all agree with me. It's also affected by your weight. How big or how tiny. Your fat level, and by the way, fat is not determined by size. It can be very tiny and you still be fat. Okay? But your weight, okay, your entire body mass index can affect your blood pressure. Your stress level, your pulse. Can you think of other factors which are inside the error term but haven't been captured here? Nobody should mention broken heart. I'm the only one who can determine what is relevant probably here. So let's see what are the relevant factors. Genetics is number one. There's no question about that. Diet is number two. There's no question about that. Lifestyle is irrelevant. Lifestyle is too broad. Other diseases is perfect. Okay? Nothing on health status. Exercise is powerful. Stop the lifestyle. You can't even count what goes into lifestyle. Hereditary has been mentioned. Somebody said genetic, family history. It's all of them, the same thing. Okay? What other factors? So you've mentioned diet. You've mentioned other diseases. You've mentioned genetics. And then we have exercise. These are the only ones, basically. They can all. So there are other factors. Somebody says financial status. Please don't bring emotion. Don't bring, broken heart. Don't bring, anything psychological should not come here. Okay? Anything psychological shouldn't come here. And when you say underlying conditions, it all goes back to the diseases, other diseases that some have already mentioned. Fantastic. Let's go to another factor. Quantity demanded. Quantity demanded of a product is affected by the price of the product. You all agree with that? Okay. It's affected by the income level of the people. the income level. You know, when your income is higher, you're likely to consume more of the quantity of a normal good. The advertisement, A, is advertisement. Advertisement can affect your quantity. Okay, sometimes the more advert that goes into the thing, the likelihood of people purchasing that thing. Then the complement price, whether it's a substitute or a complement, can determine the demand for that particular commodity. Of course, the other factors, which are all captured in the unobservables, the disturbance term, who can tell me is all of those possible factors that can also affect, but haven't been captured here. Okay, let me see. Taste and preference, please. Anything taste and preferences, take it out. Okay, I will buy seasonality. Somebody mentioned seasonality. That's good. Take away quality of the product. We can't mention that. Okay, religion is important. Okay, availability is irrelevant because you not packaging. All of these things, branding, all of them go into quality. We don't want that now. Location is critical. Location is important. What else? I think you should rather say price expectation, not customer expectation. Okay. I even mentioned that no mention of substitute and complement. Okay. No mention of substitute and complement because that is captured here already. Okay. Location. Somebody has mentioned location, so you don't have to mention proximity. Okay. Referrals is meaningless in this context. User friendliness. I've not even told you what the item is. You're talking about user. This is something you swallow. So what is user friendly about that thing you swallow? Okay. Promotion, branding, all of those things, they are irrelevant. Mention things that can be numbered, that can be counted. Like what? Expected price levels. That is good. Population. The higher the population, the higher the demand. Okay, that is good. Location, religion, occupation. Okay, that will also affect. So at least what you are seeing is that there are certain factors that cannot be captured inside the original dependent variable. So the quantity demanded is being affected by all of these factors, but there are more. There are more that have been affected. Inflation is good. All the macroeconomic factors, inflation, GDP, exchange rate, interest rate, they are all good, but I normally don't include it because it will affect, you are not doing country analysis. Production capacity, again, that is on the supply side, not on the demand side. So, you are beginning to understand the independent variables, that some cannot be captured. Now, look at the last equation I have there. It is like the first one, but there is some difference. Do you realize that there is some first one and then the last one, they are all having wage as a dependent variable. There is a difference between the two. Okay? And I want you to take your time. There are two main differences between the first one. The first one is known as regression model, specified regression model. The last one bullet is known as estimated regression equation. What is the difference between the specified regression model and then the estimated regression equation? What is the difference? If you look at it carefully, you will notice the difference. Okay. What is the difference? Okay. You have to be clear. Okay, someone has raised their hand, so let's see whether the person. I need all the two main differences. Raphael Amponsa. Raphael. Okay. Yes.
Well, sir, I see that with the estimated equation model, the error term is missing. It's not part of it.
Good. That's one. What else? Still on you. All right. Don't worry. Somebody will continue if you are not clear with that.
All right, sir. Okay, sir. All right.
So the first point he has indicated is that with the estimated regression equation, there is no error term. And you will come to understand why there is no error term. Okay? What about the first one? The specified regression model has an error term, the estimated does not. But what is that first thing? Actual values have been introduced into the estimated. So we call them, those values, what are the names? We used to call them the beta parameters. Now that they have been into, so the true values of the beta parameters have been found. And these are known as coefficients. Coefficients. So the coefficients in the original model has been identified. the coefficients have been identified. These two models are the same. The only thing is that one is a specified model and the other is estimated. Now, what eventually led to the retrieval of the numbers? What led to the retrieval of? That's what we are going to do. That's what we're going to find out. Do you remember I told you that those numbers will tell you by how much the independent variable affect the dependent variable. So suppose that education says that he is powerful enough to affect wage, and experience also say, hey, hang on, I am also powerful in determining your wage. Well, by how much? The value, the 0.85 and the 2.4 will tell you exactly the usefulness of them in determining. So what this means is that, of course, we are going to look at the interpretation deeply. What this means is that if you should increase education by 1 year, your wage is going to rise by 0.85. If you increase your wage, your education by 1 unit, your wage will increase by 0.85 units. Now, why increase? Because there's a plus in front of the 0.85. If it was a negative, it means that if you should increase your education by 1 unit, your wage will fall by 0.85 units. But if you increase your experience by 1 unit, the 2.4 means that the wage will rise by 2.5. So looking at those numbers, you can tell clearly from here, all things being equal from here, assuming that they are all measured in the same terms, you can see that experience will increase the wage by more than education will increase the wage. That is it. And this is the critical factors that are being considered in this kind of regression. So we are going to do several of these regressions. We're going to make sense of this regression. But ladies and gentlemen, this is a high level course, and so you need to understand some theoretical underpinnings. Okay? Once you understand some theoretical underpinnings, it's good. At this stage, I do not expect you to fully understand it, but I expect you to have a flair of what has been discussed. This is a general model. General models, you see, there are plenty of them. There are so many of them, and if you really want to go general, that is going to cause a lot of problem because it's so many. So sometimes we use matrices to condense the information. So every y that I have, okay, I can have data on each observation. So we'll have several of the y's, y1, y2, y3, y, all of the information on that. And then we'll have all of the information on each of the independent variables, the x1s, the x2s, the x3, for each person across, okay, across individuals. You can put all of them together and represent all of them by a matrix. And so all the y's can be represented by one big capital Y, because y is an n by 1 matrix. And then the independent variables, there are so many of them, so they are usually n by k plus 1 matrix. The n is the sample size, the k is the number of independent variables. And then the beta parameters, if you can see, they are multiplying each one of the x's. So since that one is k by 1, it will also be k by 1. But again, it doesn't have an x, so it will be multiplied by 1, like an identity matrix. And then finally, the error term is an n by 1 matrix, because every observation will have it. You don't have to understand all of this. What you have to understand is that there's something called matrix, where all of these things can be done. So y is equal to x beta plus u. Y is, see, now we've been able to condense all the complexities into this. This is a matrix. So anytime you see the y, understand that is a matrix. Anytime you see the x, understand that it's a matrix. It's made up of multiple things put together. All right. Now listen, please. Listen. Before we go into the assumptions of regression, there's something you need to note. And it is this fact. You see, going back to the equations that we had here, one of the things you should understand is that how do we retrieve this beta 1 to get 0.85? Now, behind the scenes, the processes that it goes through before getting that 0.85 is a serious thing. That beta, you don't observe it. You don't see it. And so we got to estimate it. And that is what we've estimated and gotten the 0.85. Now, because you are not seeing that beta in real life, you see, you can see the education, the number of years of work, you can see it in real life, but you can't see the beta one in real life. And so you got to assume, you got to make certain assumptions about how it is like. You know, when you don't know somebody, you make certain assumptions about how the person is like. Now, you could be right, you could be wrong, but eventually the whole thing is that if there are so many people making similar kind of assumptions, eventually we can arrive at the true value, true assumption. If somebody says he has a big head, somebody say, yeah, it's a big head, but it's not that big, it's a rectangular, and then eventually you can put that together. You know, somebody can describe somebody, and an artist can actually draw the person, and eventually the person will look like the person. The true person can come out. And that process, we call it the true value. So beta 1, there is a true value of beta. And so when you estimate this beta, which is 0.85, the question we need to ask ourselves, is that the true value? Is that the true value? So you're going to about to see certain assumptions about beta, certain assumptions also about the error. What is error term? Well, we just said some few minutes ago that this error term refers to all possible factors that have to be included, but haven't been included. But you see, they are latent. You don't have them. You don't observe them. You don't see them. They are unobservable. But they are influencing behind the scenes. They are influencing the relationship between the independent variables and how they are affecting the dependent. This unobserved factor is annoyingly affecting the relationship. And so you would have wished that the value of it is even 0. So with this, before we can run this regression and move from this level to that numerical level, we need to make certain assumptions. We need to make certain assumptions.